Coulomb's law. Coulomb's law states that the magnitude of the electric force between 2-point charges is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. The Coulomb's law formula is given by Fe equal to K times Q1 Q2 divided by R squared, where these two formulas are the same, only that the first formula is capitalized, capital Q1 Q2, and the second formula is in the lowercase Q1 Q2, where K here is what we call the Coulomb constant, which is equal to 8.988 times 10 to the 9 Newton square meter per Coulomb square, or it can be rounded to 9 times 10 to the 9 Newton square meter per Coulomb square, where Q is the charge. It is measured in Coulomb. Coulomb is symbolized by the letter C. Let us have some example problem. We have example number 1, but before that, we have to take note of the following rules in solving worded problem. In solving worded problem, first read the problem carefully with understanding. The second step is know the given and required. The third is draw or sketch if possible. The fourth, you're going to use an appropriate formula, and then with the given and required, you're going to substitute in the formula the given. Thereby, the last step is we are going now to solve the equation. Be sure that the answer will match to the required in the problem. For example, 2 charges, 2 Coulomb and 3 Coulomb are positioned 0.5 meters from each other. What force does the 2 Coulomb charge feel as a result of the 3 Coulomb charge? So, you look at the problem which states that there are 2 Coulombs and 3 Coulombs which are positively charged. And we said that if 2 charges are of the same charge, say positive, then they will repel each other. Or if both are negative, then they repel each other. What force does the 2 Coulomb charge feel as a result of the 3 Coulomb charge? So, the given here, we have the 2 charges. Q1 is 2 coulombs and Q2 is 3 coulombs. The distance between them is 0.5 meters. And we are going to solve the electric force between the 2 charges. So, using now the Coulomb's law formula, where F is equal to K times Q1 times Q2 over R squared, where K is 9 times 10 to the 9 Newton square meter per Coulomb square times positive 2 Coulomb times positive 3 Coulomb divided by 0.5 meter raised to the power of 2. Using your calculator, your answer should be 2.1 times 10 to the 11 Newton, which is repulsive. Why repulsive? Because the 2 charges are both positive. So the electric force between them is repulsive, meaning to say the 2 charges will not attract each other. They will separate ways. Now let's have another example. Example number 2. Let us read the problem. 2 other charges, 2 Coulomb and negative 1 Coulomb, are positioned 2 meters from each other. What force does the 2 Coulomb charge feel as a result of the negative 1 Coulomb charge? So as you can see again, the 2 charges are opposite each other. One is positive 2 Coulomb and the other is negative 1 Coulomb. So under the principle of charges, if 2 charges are opposite each other or oppositely charged, then they attract each other. That's the time we can say the force between them is attractive force. So the given here is positive 2 Coulomb and negative 1 Coulomb. Distance of separation between the 2 charges is 2 meters from each other. The required is what does the 2 Coulomb charge feel as a result of the negative 1 Coulomb charge. So we are solving here the electric force between the 2 oppositely charged particles. So we can use the other formula where the Coulomb constant is 8.99 times 10 to the 9 Newton square meter per Coulomb square times 2 Coulomb times negative 1 Coulomb divided by 2 meter quantity square. So of course, when you multiply positive and negative, the product will always be negative. So we get negative 4.5 times 10 to the 9 Newton. Now we can rewrite the answer by placing a positive answer. It is 4.5 times 10 to the 9 Newton, but we have to enclose in the parentheses attractive force. I hope you understand the lecture about using how to use the Coulomb's law formula and how to solve worded problems.